Hi, in this video we are going to talk about some approaches to classify objects on images. Many problems in computer vision can be seen as classification problems. We usually want to identify either an object or a scene to do something with it. The key point is to identify what are the features that we can use to differentiate one kind of image from another. We could, for example, look at these images and try to divide them into those that are natural scenes versus urban areas. Based on the current cities, we can find a pattern here. Landscapes have considerable more green and brown compared to the urban areas in which gray can be everywhere. Of course, using just color won't give great results. There are many instances in which our color rule can be broken by a scene in both classes. The alternative can be include texture. In this case, you can have a window that you can move around the image, and the idea is to be able to look at the window and identify what material we are looking at. Is it cloth, concrete, grass, wood, human skin? If we could answer this question, then we can combine this information to infer if a group of pixels are representing a piece of furniture, a tree, or a person. Different materials will produce different patterns on the image. And we can identify such patterns based on, for example, the structure of the patch. However, it's important to notice that similar patterns can come from different materials, and even the same material can be used in really different objects. So the combination of different kinds of features is fundamental for the accuracy of classification. Now imagine that you have a database of images with different scenes, and you ask somebody to mark and label the objects in the image so your classifier can learn automatically to identify certain objects. Let's think about a toaster. Are all the toasters the same? Do we really need to have an image of every toaster ever created? The answer in both cases is no. But we need to have several examples from different angles so our classifier can generalize in new images. One common trick used on training set is to transform the original images using the affine transformation. By changing the rotation and scale of an image, we are including new examples to the classifier. Here you might think, wait, that is the same toaster. And you're right. However, if you use only the original images, the classifier will learn to identify toasters of a specific size and position given the search space that the toasters in the original image represent. But when we transform the images, we are helping to expand this search space. This is necessary because we don't know where, in which position, and how large a toaster might appear in a new image. Hence, this form of bootstrapping can considerably increase the accuracy of classification. Finally, we already talked about techniques that find features on images. We can also include those for image classification. A good example can be the hog features. Using this information, we can detect, for example, a person based on specific patterns of hog features. But in the next video, we will see another technique that can be really helpful during classification. Okay, in this video, we talk about how to classify images and the advantage of combining different types of features. See you in the next video.